So in order to differentiate such a function, first of all, I need to notice that this is a product. So this is function 1 and this is function 2. Secondly, I have power 4. First function has power 4. Second function has power 8. So then f prime will be, I differentiate the first function. I bring 4 in front. I subtract 1 from the power. I multiply by the inner function prime, which is 5. And now I have to multiply by the second function. And then plus. I copy the first function. I bring down 8. I multiply by that function to 8 minus 1. And now I have to multiply by the inner function prime, which is 2. Let's take a moment and see if we have any questions on this. Any questions?
Wait, so when you add it again, you just flip, I mean not flip, but you just do the opposite of each other when when you add it afterwards?
So when we differentiate a product, we have to write the rule, and remember the rule. I differentiate the first function and I multiply by the second, and then plus, I copy the first function and I multiply by the second function prime. This is the product rule. And since this is a product, I have to apply the product rule. And because this is a function to a power, I have also to apply the chain rule. So the y prime is this. The first function prime is this. And this is the second function. And then plus. The first function is this, and this is the second function prime. Is this okay?
Yeah, I got it now.
Perfect. Now, we cannot leave it like this. We have to rearrange it. We have to try to factor in order to simplify. So I'm going to continue here, f prime of x. I will rearrange the first term as 4 times 5, which is 20. I will copy 5x plus 2 to the third. I will copy 2x minus 3 to the 8. Here I have 8 and 2 and put it in front, plus 16. 5x plus 2 to the fourth, and 2x minus 3 to the seventh. I realize now that these two terms have 4 in common, so I'm going to pull out 4. They have 5x plus 2 in common to the third power. They have 2x minus 8 in common to the 7th power. Always choose the smallest of the two. So I pull out the greatest common factor, which is 4. 5x plus 2 to the third and 2x minus 3 to the 7th power. So from the first term, if I take out 4, a 5 is left in. 5x plus 2 to the third, they're all out. But 2x minus 3 to the 8th, I only took 7 of those out. So I have to multiply by 2x minus 3. Then plus. From 16, I took out a 4, so there is another 4 left in. 2x minus 3 to the 7th is out. 5x plus 2 to the 4th, I only took 3 out, so there is 1 left inside. Of course, you know already, I always run out of room. I'm going to write this one more time because it's not clear. So 4, 5x plus 2 to the third. You don't have to write it again. So 5, 2x minus 3 plus 4, 5x. 5x plus 2. I will combine like terms here. I see 5 times 2 is 10x minus 15. 4 times 5 is 20x plus 8. So then I get 30x minus 7. So the final simplified form will be 4. 5x plus 2 cubed. 2x minus 3 to the 7th power. And 30x minus 7. And this is absolutely final. No one can further simplify that. So this was a simplification by factoring. Simplification by factoring. I put my markers here so I'm in the zone and they just mess my pages up. Any questions? Moving forward, let's look at a quotient now. Any questions about this so far? Okay, so let's look at, let's say, y equals 7x cubed over 4 minus 9x to the 5th power. Please stop me if you have questions. So I see it's a quotient. I'm asked to differentiate. I see that 7 is multiplied by x to the 3rd. This can be written like this. It's the same thing. I'm not going to mess with that number because I will eventually have to factor it out at the end, so why bother with it? It's a constant times a function. So y prime equals 7 times. The numerator prime is 3x squared multiplied by the denominator minus the numerator, but times I have to differentiate the denominator and I have to use the chain rule. I bring 5 in front, I multiply by the function raised to 5 minus 1, which is 4, times the inner function prime, which is negative 9, over the denominator that must be squared. If you remember, we do not differentiate the denominator, so the denominator only has to be squared. If you attempt to simplify in a sum, you can't get any credit. So please, I'm begging you, be very careful with this. You cannot simplify like that. But we can simplify after we rearrange everything in the numerator. Then we'll see what is common and pull it out. So let's reorganize the numerator in a nice way. So then y prime, 7 is still patient outside waiting. So the numerator of 3x, I mean this portion, this term is as is. I can't do anything to it. Negative 9 times 5 times negative 1 is positive 45. I copy x cubed, and I copy 4 minus 9x to the 4th power. I copy the denominator to the 10th power. Okay, here's what I notice in the numerator. I notice that x squared is a common factor. I notice that 3 is a common factor. And I notice that 4 minus 9x to the 4th power is a common factor. 7 is still patient. 3x squared. And 4 minus 9x to the 4th power. Okay, so let's see what's left. 3 is out, x squared is out, 5 of these are out, 4 of these are out, so 1 is left in. I'm here now, plus. 45 divided by 3 is 15. I had 3 x's and I took out 2, so 1 is still left in. And 4 minus 9x to the fourth is completely out. So there is nothing else in there. Any questions so far?
Yeah, just where did you divide the 45 by 3 from?
So 3 and 45 have a common factor of 3. If I put 3 in front, then I have to put 15 here. 3 times this is this, and 3 times this is this.
Okay, thank you.
Thank you. Is that clear? It's okay if you say no, and I'll show it again.
I got it.
Okay. Now, only now, I can do this. And then I have to combine my terms inside. And yes, now I can multiply 7 by 3. Oh, this is not good. 21x squared. 15x minus 9x is 6x plus 4 over 4 minus 9x, everything to the 5th power. I would recommend take out a 2 from here, put it in front. 2 times 21, 42x squared, 3x plus 2. This is completely simplified. I wrote 6 here and 5 here. My apologies. Why? I don't know. No excuse. It's power 6. I don't know why I wrote 5. From 10 I remove 4, and these are all gone. And this is fully simplified. And you will see in the next chapter why we need all these functions, all these derivatives to be fully simplified by factoring. Now the next step is a function, a square root, let's say, first. So if I have a square root of a function and I'm asked to differentiate it. So again, for a moment, let's look at how do I differentiate the square root of x. We carved this in stone sometime last week, which is 1 over 2, the square root of x, and I should write times x prime. Of course I will not, because it's 1. But this is the chain rule for a square root of any function. So this is 1 over 2, the square root of the function times the function prime. So let's look at an example now. Let's say y equals the square root of 4x squared plus 1. So we're asked to differentiate this function. According to the rule, 1 divided by 2, the square root of the function, multiplied by the inner function prime, 8x. Yes, I will simplify the 2 with the 8. And the final simplified form of this derivative is y prime equals 4x over the square root of 4x squared plus 1. Any questions? Any questions? Any questions? So let's look at a word problem now. Do you want, please choose, you want to practice more quotient rule, product rule, radicals with the chain rule? Would you like to practice anything else? radicals. What about a more complicated one? So we have y equals the cube root of x to the fifth plus 6x. I don't have a direct rule for this, so of course I'm going to change it into x to the fifth plus 6x. To which power?
1 over 3.
Excellent. Thank you very much. Is indeed 1 over 3. Perfect. So from here on, I'm applying the power rule on this function composition. So then y prime will be, I bring down 1/3, I subtract 1 from 1/3, 1 minus 1/3 equals negative, it's positive 2/3. In my mind I was doing the other way around, so it's 2/3, times the inner function prime. Well, the inner function prime will be 5x to the fourth plus 6. And there is nothing you can do to this. This can stay as is. This one does not need any work. Do we need to look at other rational functions or